You're listening to the Future Tech Podcast with Richard Jacobs. Future technologies such as artificial intelligence, stem cells, 3D printing, gene editing, Bitcoin, blockchain, the microbiome, quantum computing, virtual reality, and exploring space are much closer than you might think. In fact, many early versions of these technologies are in play right now, and the companies that are using these technologies are the focus of this podcast. My goal for you, the listener, is to learn from these podcasts. You may very well learn something that may change the course of your life for the better, steer you towards a new career, or give you insight into addressing a thorny medical problem. Remember, this podcast and its content is informational in nature only. No medical, tax, legal, financial, or psychological advice is being given. If you've enjoyed the podcast, please listen, subscribe, like, and tell your friends about it. Thank you. Hello, this is Richard Jacobs with the Future Tech Podcast. I have Dave Stetzer, founder of Stetzer Electric. Dave's got an interesting background, having been an electrician for over 30 years. And during his time as an electrician, he had exposure to some interesting electronic equipment through the military, which we'll talk about. So before I give away any more, Dave, thanks for coming. How you doing?
Oh, fine. Thank you.
Yeah, so if you don't mind, tell me a little bit about your background. What got you interested in electricity in the beginning, and what have you observed over the 30-plus years that really strikes you as being super important to know about?
Well, mainly a lot of the changes. I started, we were going to be drafted or else we could join the service. So I joined the Air Force because at least that way I got my pick. But back in 1970, so I went to the number one electronics school in the world. So, and when I got out of the Air Force, I just liked it. So I didn't see any ads in the paper for people wanting missiles in somebody's bedroom or something. So then electricians made more money than TV repairmen. So I guess I chose that field. So then, and then I noticed, like you said, over the course of time, the changes in the loads. The grid has changed. We used to, when you were a kid, you went over to your grandpa's house and you looked in the TV and you seen all these vacuum tubes. Well, now we have integrated circuits and things like that. So the loads have changed from linear loads to non-linear loads, and the utilities infrastructure hasn't kept up with the load changes. And so it creates a lot of problems. And so in 1980s, the Institute of Electrical and Electronic Engineers recognized this. And so they said, well, okay, look, you're going to we'll set some standards. And they come out with the IEEE 519, which puts standards or limitations of what you can put back on the grid. Well, unfortunately, they made the electric utility the policeman of it. And so then that's kind of like saying, Mr. Fox, can you come over and count the chickens in my hen house? So the neutral currents got so high that by 1992, the public service commissions of all the states, the utilities lobbied, and they put the current in the ground. So the wire that by 1998, 70% in North America, all the current that goes out on the big highline wires returns to the substation via the earth. So these are the things that, of course, happened in my lifetime, and it creates a lot of problems, not only with equipment, but with human health and animal health as well.
Well, I thought if you ground an appliance, for instance, it's for safety, and that wouldn't really affect you at all.
Well, the grounding was supposed to be like a sponge. Like if you drop water on a sponge, it absorbs it, and it's just never dealt with again, right? Well, right. In Europe, they use what we call an open delta system, where the ground is not used as an electrical conductor. And actually, the National Electrical Safety Code, Rule 92D, says that there shall be no objectionable flow of current over the grounding conductor. In other words, you're not supposed to put current in the ground, and you're not supposed to use it as a conductor. And Rule 215B of the same code says that you're not supposed to use the earth as part of the supply circuit. You're not supposed to use it as a wire. But the electric utilities still use the earth as part of the circuit now. They're using it. In 1998, 70%, like I said, of all the current that goes out returns to the substation via the earth. So those are old figures, 1998. I mean, they're 20 years old. So, what's happening is there's a whole lot more now. And where do you stand? On the ground. Where are your water pipes? In the ground. So when you go to get a drink of water, there's something called contact current that you can get with a measurement between the sink and the floor, for example. So this current's going up one leg and down the other. If you're standing out on the earth or getting a drink of water, taking a shower or something, you're actually getting current flowing through your body.
So how much current, and how do you think this is affecting people's health?
Well, how much current? It only takes 18 microamps. That's associated with cancer in numerous well-programmed studies, according to the National Institute of Health and Environmental Sciences, and I measure that all the time. That only has to be like 5 millivolts between the sink and the floor. And if the body's 500 ohms of impedance, which is the standard UL accepted model, then you would have 18 microamps. 60 microamps will stop the heart of a dog. 80 microamps will stop a human heart. So these levels are very dangerous levels, yes.
What about smartphones and people constantly being around computers and phones and holding them? How is that interacting with the ground currents they may be exposed to, and is that presenting another challenge or another problem to them? That's
a total different problem. Those are much higher frequencies, and they with the cell phones, wireless technology, that's energy coming through space. You should limit your use to that. There's probably, you can use some shielding, things like that, but Wi-Fi, you don't want to shield it because you need it to communicate. So I always tell people, well, just go back to the Ethernet cable and use that. It's faster and it's more secure. Do things like that. We're in the 21st century. People are going to use cell phones, but keep it on airplane mode as much as you can. Answer your calls. Check your messages, things like that. Return the calls, and then go back to airplane mode. Distance is a big thing. If you're sitting next to, like in the office or something, lay it in a windowsill or something so you have time to get up and go get it. It's close enough, but if you can keep it farther away from you, better off you are.
So in regards to being connected to ground, I've spoken to some people that are advocates of earthing. That seems to be the opposite of what you're saying.
Yes, people have not taken measurement. Okay, if you're working in front of a computer, for example, you will build up a charge. The body has capacitance. That charge, you will hold the charge. If you're working underneath fluorescent lights all day, will you build up a charge? The answer is absolutely yes. Now, is it good to discharge? Yes. You can discharge by standing on a piece of aluminum foil for less than a minute, and we can measure this. We have instruments that are bought, and that you can actually measure this. You can take an Epsom salt bath. You can do things like that. But to connect yourself, now remember, all this earthing stuff, that research was done in Europe. Europe doesn't use the earth as part of the supply circuit. So now, would you consider climbing up the pole, the electrical pole out in your yard, connecting a wire to the bottom wire of the power line, coming in and connecting it to a mat and then lay on that mat? Probably not. Well, that's what you're doing in North America when you connect yourself to the earth or ground. It is not at zero potential. You can take a voltmeter and go between the two, for example, your ground plug and where your earthing mat or whatever, and you will see that there's a voltage potential. You will charge up more laying on this earthing mat. I know no one who's gotten better from using earthing or grounding here in North America. In fact, quite the opposite. And we've done reports for people and the measurements. And we have the measurements. Meters don't lie. Meters don't have opinions. Meters are just ones and zeros. They're binary.
So traditionally connecting to ground, the ground's supposed to be at zero potential, and then it'll discharge any residual potential you have in your body. But the ground now, does it even act like ground? You don't have the ability
that's about it. And if you're going to simplify it, that's about right in a nutshell. Like I said, the ground at one time should have been like a sponge, like where you put water on the sponge, it's absorbed, it's, equalizes, you just don't have anything to deal, you don't have to deal with the water. But now in North America, the ground is actually like a wire. It's a live wire. So you don't want to connect yourself.
So if you go to earth yourself, would you then build up more charge?
Yes.
Or would it just not dissipate, or will it happen?
Not only will it not dissipate, you'll build up more. You'll actually connect yourself to a live wire.
Well, why would the charge not have time to dissipate locally on the earth around us? Or the earth's so huge, I thought that was the original theory of grounding, that it's so massive, it's just a gigantic sink for current.
It's like a sponge was the idea, okay? When you put water on a sponge, how the sponge absorbs the water, you don't see it.
Right.
Now it's like putting water on a brick. You got to deal with the water. Okay, in North America, we use a grounded Y system. The bottom wire of the power line is connected to the earth on almost every pole. If you drive down the road and you look at the bottom wire, you'll see a little loop and you'll see a wire coming down the pole, goes into the earth. Again, in 1998, 70% of all the current that went out on the phase conductor. And that study there was two studies. One was done by EPRI, Electrical Power Research Institute, which is the electric utility's own research arm. And the other one was done by the Minnesota Science Advisors. And both of them found that 70% of all the current that goes out on the phase wires returns via the earth.
I guess my immediate reaction is that maybe the electric company would earn back most of its money and charge you again for it by doing that, or is that
no? It doesn't work that way. It's sort of like a hydraulic system in a tractor or something like that. You have this pump that pumps out this pressure, and it goes through the motor, and it runs this mower or whatever, and then there's really no pressure on the other side. It drains back into a reservoir. Well, this is sort of like the hose that brings it back. So you have to take that oil and pump it again, okay? So you have to take that from the substation. And
you don't have to generate it, though. I would think it would reduce the required generated
load.
No,
because you still have to generate the power. These are electrons. Current flow is electrons, see? The pressure's gone. You need the pressure to push it down the line.
Okay. So what happens? You said it returns to the plant, and then what happens? Does it just dissipate in that area?
No, it gets pumped out again.
Charge?
It's like an oil reservoir, it gets pumped out again. It gets shipped out again.
I mean, wouldn't there be more electrons then pumped out? Because the plant is
still
creating
you got to
power.
remember, electricity is governed by the laws of physics. There's Ohm's law, Kirchhoff's law. And Kirchhoff's law says for every electron that leaves a node, one has to return. Well, that substation's a node. And so those electrons are pushed down the line, okay? So for every one that goes down the line, it goes through, light your light bulb, whatever, okay? One has to return back to that substation. So in other words, if you have a load that's 50 amperes going out, you got to have 50 amperes coming back. Again, you can't pump 10 gallons of oil per minute if you only got 3 gallons of oil in the reservoir.
Right, but you're saying, I guess, in a sense, the oil is returning. It's just not pumped up.
It's being circulated. It's being recirculated, you could say.
How do you think this is affecting people on the ground and plants and animals?
Well, okay, we've done a lot of research with this, and cows are one of the things that we did. And we measured, we used I think it was 4 different instruments and 3 different manufacturers. But we used these instruments and we would measure the power quality and we measured the ground current. We put 2 plates on the barn floor where a cow would stand 5 feet apart. So we knew what the voltage, we recorded the voltage, what the cow would feel. And there's a 99.9% correlation between daily milk production and the amount of electrical activity that's on that barn floor. So it definitely affects a cow. It definitely affects pigs, okay, that we've done actual research on. This stuff is published in peer-reviewed journals. We've done it. We did it for 500 and some days, collected data. So it wasn't like something that just happened overnight. Like I said, we used different instruments and we did different manufacturers, and we come up with the same results. The worst correlation we got was a 96.5% correlation.
What's the correlation? What happens when there's more electricity flowing in the ground?
Well, the more often the cow gets shocked, these transients, or high voltage transients that we're exposed to on the ground, from like motor starts, high energy efficient things, switch mode power supplies, dirty power, whatever, okay? So when you get the more shocks they get, the less milk they give. On the day they got less shocks, the more milk they gave. On the day that they got hardly any, or the least amount of shocks, they gave the maximum amount of milk. If there was a day where they got all of a sudden, something happened where there was a lot of shocks, then the milk production took a big fall. And again, it wasn't something we did for a 2-week period. We did it on several farms in several states. We always took at least 5 farms in a row. So the day one guy's milk production went down, so did the neighbors. The day one guy's milk production went up, so did the neighbors. So there's only 2 things they got in common. One is the weather, and the other is the electrical grid.
So if you live right across the street from a power plant, bad news.
Bad news.
Maybe the more rural area, not so bad, maybe, right?
Yeah. Mm-hmm. Yeah, you got it. Yeah. Right. One of the places you don't want to live is next to a substation.
What about, is it just distance away from the power generation, or is there a path that you can either be in the path of or not in the path of, and then you'd be in better shape or not?
Yeah, that's true. Okay. But you got to remember the theory of Kirchhoff's law. For every electron that leaves the node, one has to return. Okay, so if you live next to the substation, that's a big node, okay? So all the power that goes out has to return there. Well, 70% of it has to come back, is coming back. Well, it's more than that now, but say 70-80% is coming back on the Earth. So if you're living next to it, you're getting the majority of it, where if you live 5 miles away from it, or 3 miles away from it, then you're only getting probably what's coming from that circuit, what's out beyond you, beyond you in the substation.
Again, the worst place to be would be near a substation and in the path of other electricity.
Like next to a creek or something
substation,
where the water is, we have more conductive soil, or, like a creek or a low-lying area or something where, you have a lot of moisture and stuff, so the ground would be more conductive.
I guess a rock and a hard place to live would be like between two substations, or between major power generators and the substation, right?
Yeah, right. That would be kind of a bad scenario.
So what can be done? Now that you've figured this out, what do we do?
Actually, the fix is rather simple. We go back to the laws of physics, the laws that govern it. Current takes the path of least resistance is Ohm's law. Well, what happens if we have these three conductors, coming out from the substation, taking all this current out? Okay, well, we want it to come back. Well, if it comes back on a wire, then it's not running on our water pipes. It's not running through our homes uncontrolled, you understand? Or over the earth. So now, if the wire is too small, why put it in the ground? Just put up a bigger wire. Current will go on the wire rather than the earth. The New York Power Association did some research with Electri many, many years ago, and they put another line was to put up a bigger wire. Okay, it's like an overloaded sewage system. If you have 10 houses on each side of the street with 10 couples, living there, then 20 couples total. Okay, and you have a 4-inch pipe coming out of each home going over to a 16-inch sewage system pipe, and everything's working fine. But then what happens? Those 10 couples have 10 kids. Now you're flushing the toilet more often. The load's changed. Washing more clothes, things like that. Now that 16-inch pipe plugs up. Well, there's several ways you can fix it. One is dig up the street and put in a bigger pipe, right? Or you can dig up the street and you can put in another pipe, okay? Or, because that pressure is building back up. You're getting sewage bubbling in people's basement. So to get rid of the pressure, you could just dig up the street, or not even dig up the street, just drill holes down in the street into the pipe. Now you got the sewage bubbling up out. You don't have the pressure there. And that's basically what the electric utilities did. They drilled a hole in the pipe. What they did is they hooked the ground rod in every wire or pole, and they put the current in the ground. So now once it's on the ground, it flows uncontrolled over the ground. Now, you can go back to that analogy. You can go ahead and put up a bigger wire, or you can put up another wire. And like I said, the New York Power Association did some research, and they monitored stray voltages, or they called it, and right, EMFs, and then out of one circuit for a year. Then they put up an additional wire. The EMFs went down 50% and the stray voltages went down 40%. But they admitted it would have been done better if they'd have done all the circuits, but they only did one circuit out of that substation. So the fix is really relatively simple, inexpensive.
Oh, I mean, I guess the issue is pretty much no one that I've ever heard of is talking about this. And how do you call attention to this and get people to take action unless they feel pain from it?
The intention is there. People, they know it. They have engineers that are smart. They know it. But the problem is years ago, the guys that used to run the power companies probably climbed up a pole, and hooked wires up or something. Now you have MBAs that don't know an electron from a ground rod running these companies, and engineering is a side thing. It's not really a priority there. They're more interested in making money for the stockholders and things like that. So engineering and infrastructure gets to be kind of, and politics gets entered into it, which shouldn't be. Politics, this is an engineering problem. It's an engineering solution to an engineering problem. And you can move up the ladder so far, and then when you get into the politician realm, then it doesn't get fixed. Nothing gets done.
So are you personally working on some kind of solution to this, or what's your role? That you've documented it, but what's next?
There's some things that we can solve, okay? Like computers, for example. They don't use the vacuum tubes, they use switch mode power supplies. So like a tower, like a Dell tower, for example, will put 16.6 kilohertz back on the line. Mac computers put 12.5 kilohertz back on the line. These compact fluorescent lights that everybody was so crazy about for a while, put between 50 kilohertz and 100 kilohertz back on the line. So it gets on every wire in the house, which capacitively couples into the human body, which affects our health. So in theory, when Michael Dell makes this computer, and if he knows it's putting 16.6 kilohertz back on the line, he should say, okay, let's get rid of it. Let's make a tuned filter for 16.6 kilohertz. But he doesn't do that because it would add $5 to the cost of the computer, I would imagine. I don't know why he does. So then what happened is nobody would do this. When Graham and I, Martin Graham, who was a professor emeritus from UC Berkeley, who was my best friend, and we were partners for years, and he had over 40 patents to his name. So we went to these different manufacturers, and they said, well, it'll add $5 to the cost. Get out of here. So we developed a filter that takes between 2 kilohertz and 150. Well, it goes out past the megahertz, but it goes out. And it takes these frequencies off the line. Now, the World Health Organization said that 4 kilohertz and 100 kilohertz, between the two, are the most biologically active frequencies. So that's why we targeted. We developed the filter. They will take that off the wires. As far as the earth, the ground, the currents in the ground, I can identify it, measure it, and tell people. But unless the electric utility wants to cooperate, it doesn't. And I won't say they don't cooperate. Most of them don't. But some of them do, and when they do, the results are phenomenal.
But if you live in a home or an apartment, how much problem can you reduce for yourself by I don't know what to call it, shielding, but filtering all the appliances and things in your home at least? You can't work with the ground stuff. I guess that would be the way to start, right? Is to get all this stuff filtered. So how much of a beneficial effect would it be to filter all the appliances in your home and do your whole home up? And, there's nothing you can do about the ground portion, but how much would that help you?
Oh, it would help you immensely. There's been a lot of research done with the filters. First of all, you only have to filter like your electronic loads, and then you might need some because of the neighbors and things like that, other filters there. So you don't need one in every outlet or every circuit or something. You need to put the filters in. But it would help greatly, and there's research that's published in peer-reviewed medical journals. We've taken, not we, I use we lightly, but people have taken diabetics. Now, if you say you have a headache and we put a filter in and the headache goes away, and you say, well, yeah, the filter caused my headache to go away. Well, did it or didn't it? Because only you know for sure. But if you take things like blood sugar, like diabetics, which there's 22 million diagnosed diabetics in the United States alone. But if you take diabetes, it's a number. So we can take your blood sugar. Then you get a number. Then you put some filters in your house, and you get a number on the wall, okay, how strong these high frequencies are. Then you take your blood sugar. Within 20 minutes to an hour, the blood sugar will change, okay? Dramatically, all right? Neurotransmitters is something. There was research done where the Olympia Washington Library, they took 12 people, and they took their neurotransmitters. That's the electrical grid for your immune system. And so you don't want to have any in your urine. You don't want them coming out of your body. But nobody had less than 300 neurotransmitters in their urine. They checked their urine for 12 weeks. Then they put filters in. The next 12 weeks, they checked their urine. But within 8 hours of the first day after those filters were put in, nobody had more than 3 neurotransmitters in their urine. Saliva, pH in your saliva. You can check your pH. You can put the filters in. 2 hours later, those little litmus strips, you'll be more alkaline. That's a number. Again, plotted against the number. So and this stuff is written up and published in peer-reviewed medical journals. 37 kids.
Have you filtered? How many people's houses, approximately have you, their houses?
It has to be thousands and thousands.
What are some of the anecdotes from them? What do they tell you they feel like? How do they feel differently?
Well, after they're put in, usually people will say, well, gee, I feels like the air is much cleaner. Well, it doesn't clean the air. It doesn't have anything to do with the air. What it is that your body has a reaction to these fields, just like you would have say you and I are allergic to cats, and somebody brings a cat into the room.
I am.
Okay, well then you'll know your body produces histamine. Okay,
right.
So what do? You take an antihistamine. So, but you might start wheezing. I might start to get a rash. Somebody else's eyes might start to, so we can all take antihistamines, or we can do one thing better: get rid of the cat. So that's what the filters do. These fields cause an allergic reaction to people, and your body's producing histamine. So if we put the filters in, the air didn't get cleaner. It's just that you don't need the antihistamine. Your body stops producing the histamine, so then it's like you can breathe better. The air is cleaner. So that's usually the biggest thing that we hear first, right away. But blood sugar, people who are diabetics, that's instant. There's nobody who is diabetic that shouldn't have these things. I mean, they cut their insulin usage. There was some research done. Nobody had less than a 52% reduction in insulin usage, up to 92%. And those are the type 1 diabetics.
Yeah, that's amazing. What are the filters like? Are they just?
It just looks like a little cell phone charger. You get a meter. You got to plug this meter into the wall. You're going to get a number. It's a digital number. It's printed out. It's looking at dV over dt for the engineers that are listening, but it's measuring how much energy's there. High frequency energy. It doesn't care about the 60 cycle. So you plug this meter in. You're going to get a number. And then you plug the filter in. And if you see the number reduce significantly, and I define significant as 20%, but if you see it reduces significantly, you leave the filter. Then you go to the next outlet. And you just work your way around the house. The average house takes about 20. The average house has 2 TVs and 1 computer. Depending on how dirty the neighborhood is and where you're at, okay, it'll determine how many filters you need. And the results are immediate. It's faster than penicillin.
So they just clip onto the outlet, or how?
They just plug in. They just plug in.
They plug in. Okay.
Yep. Yeah, and it looks like I said, like a cell phone charger or something like that.
Very cool. And where do you have them for sale?
Well, you can call here or go to StetzerElectric.com, and we do have some. If you go on StetzerElectric.com, they'll list some distributors and things like that. I think some of the distributors buy them and sell them on Amazon. Things like that.
And how much does it run approximately to do a whole house?
Well, the whole house with a meter, you want to get a meter too. About $700-800, $700, something like that.
Okay. Can you start with one room and test the effects of the meter and then kind of be emboldened to do the whole house, or do you recommend it all or nothing, do the whole house?
You can, but there's 100% guarantee. So right. Get what you need to do it, and if you get the results, it's cheap because they don't wear out. It isn't like a refrigerator filter that you have to replace after so many hours of use or days or something. They shouldn't wear out. I mean, they're not made to wear out. It's not a removable part or anything like that. So I mean, I got them sitting here since 1998 on my desk, and they're still plugged in. So, but do that, and then if don't work out, if you overbuy, send the other ones back. Buy 20 filters and you put them in and you get the job done and the numbers don't come down anymore and you got them with 15. You don't need to look at 5 filters sitting on the counter. So send them back. Get your full refund.
No, I got you. I just wonder if anyone does it just in their bedroom for starters.
You can, but usually it doesn't, because if I was going to do any room in the house, I would do the bedroom. Try to get it done. That's what I mean, yeah, because you're there. But the problem is whenever you plug one in somewhere, it affects it everywhere. And so
it shunts it.
Yeah. So what happens is, if you're in your bedroom, you do the bedroom and somebody comes home and watches TV, then the numbers go up and down in your bedroom too. You want to get do the TVs and the electronics first because you need one there anyway. Then work your way around. But I guess when my kids went to college, we did their dorm room. Well, you can't do the whole dorm, but we could do their rooms. Now, was the numbers where we wanted them to be? No. And even people who work in offices, like in cubicles and things, they should really do the whole office. But, if the boss or whatever doesn't buy into it or something, at least they can clean up their own cubicle a little. You're not going to get the numbers where it would be really nice. But if you're reading 800 and you go down to 100, that's a whole lot better or less energy than 800.
And you link it to each device? Like if I need one for my fridge, one for my stove, or do you just plug it into the outlets and you go by
you need one for sure on your computer, and you need them on your TVs. And when I say TV, I mean, like the DVD and the VCR and all those things, okay? And when I say computer, that includes your printer and, the CPU and all that. Okay, so you need them there. Then you go around and you check, but you don't need one on your refrigerator because your refrigerator doesn't cause it. Your stove doesn't cause any problems. The dryer doesn't cause any problems. Some washers now, the front loaders do. So you usually don't need them on those appliances there. You don't go by the appliance. You just go by you plug the meter into the outlet. If you get a number and you plug the filter in, you see a big reduction, 20%, you leave it there. If you don't see that reduction, don't worry about it. Go to the next outlet.
So is it per appliance or is it per outlet?
You check every outlet. Okay. But you could have 100 outlets in your house, and you still could get by with 10 filters or something if you didn't have a lot of electronics equipment, see?
Okay.
And then I do the kitchen last, mainly because you want to see, you need the outlets for one thing, okay? And sometimes there's split circuits there and things like that. So every time you plug one in somewhere, like I said, it lowers the numbers everywhere. So when you get over to the outlet in the kitchen, you probably don't need any.
How does the filtering work? What does the filter do? Like, how does it mechanically work?
Well, these high-frequency transients...
without giving away
No.
secrets.
No. What it does is shorts out these high frequencies, okay? You have an AC sine wave. There you have a black wire and a white wire, and they're really close to each other, okay? In this cable that feeds your outlet. And so the black wire, we call it the hot wire, and then the white wire we call the neutral. But those, if you looked at it with an oscilloscope, they're always 180 degrees out of phase with each other. So when one's going positive, when one's negative, positive, okay, like that, okay? So what happens is we're taking something on the positive wire and we're putting it on the negative wire, and vice versa, okay? So when you get these, say it's going in a positive direction, this transient, it just moves it over to the other side, and then it becomes a negative. So what's plus 10 and minus 10? Okay. So it shorts them out.
Gotcha.
Now, if you took the black wire and the white wire and touched them together, of course, boom, you blow the circuit breaker.
Well,
but that's the 60 cycle. But we're not affecting the 60 cycle at all. We're just taking the stuff off the 60 cycle. It's like going to Mexico and getting a glass of water, and you drink the water and you get sick. Well, okay, I get sick from the water in Mexico. Well, did you or didn't you? Well, let's take the water and let's just drain the glass and what's left over. Well, what's left over is the bacteria. That's what made you sick, okay? So here's this high-frequency transients that's on this 60-cycle waveform. Okay, we removed the transients off the 60 cycle. The 60 cycle's still there. We need that to run our equipment, cooler food, lighter lights, whatever. So we didn't affect that part. And so that's why your circuit breaker don't trip or anything like that. We're shorting it, just the high frequencies, and nothing happened. As far as, the electrical integrity, I mean, you're going to run your stove, your refrigerator, everything is going to run actually better.
Does anything happen to people's electric bills, or they're just totally unchanged?
Okay. In most cases, the electric bill goes down. And the reason is, and then, of course, now some people, they're kind of scam artists and stuff. And they'll say, they noticed that it went down. So what they do is they say, okay, here, look it. We'll go ahead and, the electric bill goes down by plugging these in. We're saving energy. You don't save any energy. If you read the electrical engineering handbooks, okay, it'll say, what do these high frequency transients and harmonic currents cause? Well, they cause appliances to overheat. They cause all problems. But one of the things it causes is your meter that's measuring the current, it causes them to read inaccurately because the meter is calibrated for 60 hertz. And now you have, 50 kilohertz.
You got noise on top of the signal, and you're taking the noise away. So it's
and the
accurate.
noise it's noise is what you want to call it. Okay. So what happens is it causes the meter to read inaccurate. So now if you come in and you put these filters in, your meter will read more accurately. So if your meter is now reading accurately, you're getting charged for exactly what you use, not what, it's like going to the gas station and you got to fill up your car and you put in 30 gallons of gas, but you only got a 20-gallon gas tank. You're getting cheated.
So how much on average do people's electric bills change?
About 30%. We've got, I haven't heard anybody more than 30%, but if I was going to say, most people will say about 30%. Can't say it's going to lower your light bill because what if your meter's reading accurate?
Right, that's true. Yeah.
But it will cause your meter, that's an engineering claim, can be backed up with meter measurements, okay? It will cause your meter to read more accurately.
That's really cool. Any other ancillary effects you've noticed that are strange, maybe you either can't explain or just, jump out at you and are super interesting that we haven't talked about?
Well, as far as the electrical theory?
Well, you've been doing this for a long time, and you've seen a lot of people.
I guess.
People, so
what raised me is the corruption. People know about this. It's very corrupt, the system. Like I said, when politics enters in, the state attorney general in Michigan sued Consumers Energy for putting current in the ground and causing damage. The case, it looked like the attorney general would win. All of a sudden, the case gets tanked, right? Why? Yeah. Well, then Jennifer Granholm, who was the attorney general, went on to become the governor of Michigan. Now, Jim Doyle, who was the governor of Wisconsin, was asked to join that lawsuit. And I was actually at a meeting when they were there. And, he was going to look into it. And, these people were, and same way with Hatch in Minnesota about joining the lawsuit, against the utilities. And then all of a sudden, nothing happened. And what happened? Doyle goes on to become the governor, and Hatch goes on to run for governor in Minnesota.
Okay.
So you can see, and then of course the governors, they go ahead and they appoint the public service commissioners. You see,
right.
And then there was a guy in Wisconsin who supposedly was supposed to be this SWAT team. They call it SWAT, SVAT, Stray Voltage Attack Team. And he was supposed to go out, and if he said, okay, Xcel Energy, for example, you got to build a new line, they'd have to build a new line. He was working for the Public Service Commission, right, for these stray voltages. To my knowledge, he never found the utility liable for any of the stray voltage problems. And yet, when he go out, all right, then now that he's retired, right, off the state, because he's supposed to be totally neutral, now he works for the electric utilities as a paid consultant. Against the farmers who he's supposed to be neutral to begin with. See, so you can see the corruption. I guess I'm getting older, and I don't really care what I say anymore, as far as the truth. And it's so corrupt, it's unbelievable.
But last thing is, so where can people get the filters? Let's state your website, and then we'll close from there. So what's the website again?
It's StetzerElectric.com. And I would suggest calling. If people would call, they would probably give you a better deal.
All right, very good. Well, Dan, thanks for coming on the podcast. I appreciate it.
Yep. Okay, no problem.
You're listening to the Future Tech Podcast with Richard Jacobs. Future technologies such as artificial intelligence, stem cells, 3D printing, gene editing, Bitcoin, blockchain, the microbiome, quantum computing, virtual reality, and exploring space are much closer than you might think. In fact, many early versions of these technologies are in play right now, and the companies that are using these technologies are the focus of this podcast. My goal for you, the listener, is to learn from these podcasts. You may very well learn something that may change the course of your life for the better, steer you towards a new career, or give you insight into addressing a thorny medical problem. Remember, this podcast and its content is informational in nature only. No medical, tax, legal, financial, or psychological advice is being given. If you've enjoyed the podcast, please listen, subscribe, like, and tell your friends about it. Thank you.